Hey everybody, Mr. Changer here, your neighborhood planetarium director, with a special comet hunt here for April and May of 2020. Since we're all stuck at home, something that you can be doing at night is trying to find a comet in the sky. There's one that's going to be appearing and getting brighter as we go from April into May, even into June of this year. Now, it could take a little bit of practice, but I'm going to show you some basic steps and give you some resources of how to start looking for this particular comet. All right, let's start off with what a comet is. So sometimes astronomers refer to comets as dirty snowballs. They're like big balls of ice with some dust and rocks thrown on top of them. Comets are different than asteroids in that comets are, we usually think of as mostly ice and snow and things like that, and asteroids are mostly rock and metal. Now, it can get kind of blurry in between where asteroids and comets kind of change over, but that's the main difference, that we usually think of comets as mostly these ices. Now, when I say ice, I don't just mean water ice. Out in the freezes of space, there are lots of things that we have here on Earth that are gases that when you put them out into space in these extremely cold temperatures, they become ice too. So there is water ice there, but there's also carbon dioxide, carbon monoxide, methane, things like that that we don't really think of as ice. In astronomy, we call those volatiles, things that can change states very drastically depending on how you heat them up and cool them down. So that's mostly what a comet is. If you want more resources on this, along with this YouTube video down in the description below, I'm going to link this slideshow, and all of these links here are some of my favorite resources. So there's Crash Course Astronomy here, a video on comets that's about a 10-minute video that'll talk to you about that. There's a NASA game over here on comets and some info on the NASA Rosetta mission. That's what this picture up here is from, the Rosetta mission. This was back in 2014. Along with the European Space Agency, NASA sent an orbiter to go around this particular comet. This particular comet, it was called 67P Churyumov-Gerasimenko, and it had a little lander called Philae that came off of that Rosetta orbiter and attempted to land on this. So we got some really close-up pictures of this and expanded our understanding of what comets really are and how they act out in space. Now, the comet that we're going to be looking for is called C2019 Y4ATLAS. Now, it's called C2019 because it was discovered at the end of 2019, I think December 28th. Y4 has something to do about it. It was the fourth object in a series that was discovered. And ATLAS stands for the Asteroid Terrestrial Impact Last Alert System. That's a device, I believe it's in Hawaii, that's designated to help find objects that are close to the Earth that could possibly impact it. Now, this particular comet isn't going to impact the Earth. It has no risk of it at its closest to Earth. It's going to be about 73 million miles away from us. So it's staying pretty far away from us. As you can see here in this illustration, this is our solar system with the sun in the center here. We can see Mercury, Venus, Earth, and Mars going around. So this is the inner solar system with our terrestrial planets. And this white line here is the path of this particular comet. Now, right now, as we speak here at the very end of March, in the beginning of April, it's just coming in here through Mars's orbit. So it's somewhere along here in its path. As it comes in, it'll get to here, its closest point to the sun, what we call its perihelion. That means closest to the sun, around May 23rd. So it's going to be traveling around this area of its orbit between now and May 23rd. Now, as comets come in, they get closer to the sun. A couple of things happen. They speed up and they start moving faster. This has to do with the physics of how planets and objects go around the sun. As they get closer to the sun, they move faster. Now, there's a much more dramatic difference in this for objects like comets, because you'll see they're on what we call highly elliptical orbits. They're these big ovals that come in and go really close to the sun. When it's closest to the sun, this will be about 23 million miles away from the sun, and then goes way out many, many, many times further away from the sun than Pluto does. So it really travels a large distance in our solar system, and its speed changes a whole lot here. Um, this one it takes, from what we've calculated so far, we just discovered it back in December, when it was back here, and we've only seen a little bit of its trail. But mathematically, we can calculate what its orbit is once we see it a little bit. And what we can tell right now, it looks like it has a period of over 5,000 years. So it takes over 5,000 years for this object to go around the sun just one time. So this will be our only time we ever see this object in our lifetimes. So if you want some resources right over here, here's 3 of my favorite resources. Again, I'll put this slideshow in the description so you can click on these links then. Astronomy Magazine, Universe Today, and Sky Telescope Magazine all had articles on this recently if you want to learn more in depth about this particular comet. So why does this thing take so long to go around the sun? Well, it has to do with where it lives. We're pretty sure, so these comets are leftovers from the early formation of our solar system, and they never got formed into planets and things like that. They're just kind of floating around out there. There's 2 major regions in the solar system that we know of where this comes from. The most famous one might be what we call the Kuiper Belt. This is the area out around Pluto. Pluto is a Kuiper Belt object. It's one of these objects. There's actually thousands, if not millions, of these little tiny objects moving around out by the orbit of Pluto. We can see here in this diagram, if this is the solar system, out here by Pluto would be what we call this Kuiper Belt. Now, even much, 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 much further away than Pluto is about 50 AU, or 50 distances from the Earth to the sun. Well, at 100,000 AU out, we believe there's this region that we call the Oort cloud, which is this big, almost globe, from what we can tell, around it. Now, this is something we don't have direct evidence of. The objects out here are very small. They don't give off any light. They're so far away from the sun that they don't reflect a lot of light. But we can infer, which means kind of make a really good educated guess, that they're out there, because all of these long period objects, these comets like this that take 5,000 years to go around the sun one time, have to be coming from somewhere. And we see them coming in from kind of all different directions. So we can kind of conclude that there's this big cloud of objects out there around our solar system, and we refer to that region as the Oort cloud. If you want to learn more about the Oort cloud, you can see there's a crash course video on the Oort cloud and Kuiper Belt objects right over here. Now, as C2019 Y4ATLAS gets closer to the sun, it's going to get brighter in our sky. As this comet was out in the Oort cloud, millions and millions and millions and millions of miles, billions and billions really of miles away from the sun, the heat from the sun doesn't really affect it at all. It was just a chunk of ice and rock. In the next couple months, as it comes in here closer and closer to the sun's energy starts affecting those volatiles, those ices on this. And as they warm up from the sun, they do something that's called subliminate. Subliminate is kind of like melting. When ice goes from a solid to a liquid, we call that melting. And then when it goes from a liquid into steam or a gas, we call that evaporating. Well, this process out in space doesn't happen like this. Things like these volatiles go directly from a solid right into a gas. They don't turn into a liquid at all. And we call that sublimation. So we say that it subliminates. So as these volatiles subliminate, it pushes these dust and gas out into space, and it starts to reflect more of the sunlight, and that's why we start to see them, and they get brighter, and they start to develop these tails. So here's a picture of a different comet that was imaged, and you can see it has 2 different tails from it. Those different tails come from different processes, different ways that the sun interacts with this comet. If you want to learn more about that, take a look at these videos and these articles up here. They can talk a lot about these comet tails. And as it gets closer, it's going to start to get brighter. And this is when we might be able to start finding it in the sky. Now, when it comes to comets, it's always kind of unsure whether we're going to be able to see them or not. It depends on how bright they get. So let's talk for a quick second about how we measure how bright things are in the sky. We have something in astronomy we call apparent magnitude. That's how bright things appear to us in the sky. Now, something could be really, really bright, but really, really far away, so we don't see it really well. So apparent magnitude is how it appears to our eyes when we look up into the nighttime sky. And we rate it from 30 to negative 30. Now, it's a little bit weird. The brightest stuff has the lower numbers, and the dimmest stuff that we can't see has the highest numbers. So it kind of works backwards from how it usually does. So here on this scale, we can see some things like the sun. We say that its apparent magnitude is about a negative 26. That's super, super bright. You can't even look at it. The full moon is about a 12. Venus, which we can see in the sky right now at its brightest, gets to about a 4, a 4.4. Sirius, the brightest star in our nighttime sky, is about a magnitude 1. We call it a first magnitude star. Polaris is Sirius is about a negative 4, negative 5, almost a negative 1 magnitude star. Polaris is about a second or third magnitude star. The dimmest thing that we can typically see with our eyes is about a 6. And then the very dimmest things that we use, like the Hubble Space Telescope to look at, would be like a 28. So people's eyes are limited to about a 6, but that's only in perfectly dark skies. Really here with our light pollution, maybe a 4, maybe a 5, depending on how good your eyes are. And stars are single points of light. Comets are a little bit spread out. So it all depends. Now, with scientists' best guesses right now, they think that this comet could peak anywhere from a negative 6, which would be over here, which is brighter than Venus in the sky, which would be amazing, down to like a 2, which is Polaris, which is a really dim thing, and especially for a comet. Now, I can say definitely we have no idea if you're going to be able to see it. One scientist said comets are like cats. They have tails and they do whatever they want. Because these comets are made up of these ices, these volatiles, as they get closer to the sun, we have no way to predict exactly how much they're going to outgas and things like that. Sometimes they just completely disintegrate into space. All of the ice gets exposed, it subliminates, and basically the comet just breaks apart and fades out, and we never see it. So if it stays together, it could put on a really, really neat show in the sky, and we could see it really, really brightly, or it could completely fizzle out and we won't be able to see anything. Now, it should be at its last reported brightness, it was about an 8, which you can't see with your eyes yet, but you could see with a pair of binoculars or things like that. Now, let's get a little bit more familiar with this idea of magnitudes. Let's look in the nighttime sky and see what that might look like. So here's a look at the sky magnitudes of the sky tonight. So just this week, this first week in April here, if you go outside, this is at about 9:30 at night. Look towards the south. You can see this winter triangle that we found before. Sirius is the brightest star in the northern sky that we can see in the winter. Here's Orion with his belt. His one star, Betelgeuse, is another corner of that. And there's another star, Procyon, here that make up this winter triangle. So if you look for this, that first week of April, so Sirius is a negative 1.5. And we're saying that possibly this this comet could get up to a negative 6, so even brighter than this. Procyon is about a 0. The moon this first week, first quarter moon, gets up to about a negative 11.8. And over here, the planet Venus, that what looks like a really bright star in the sky until about 10:30 at night, has a magnitude of about negative 4. So that's kind of a comparison of what you can look at to get a better idea of magnitudes. Now, let's talk about where you can look for this and how you can look for this object in the sky. So here's a look at our nighttime sky. This is facing north. This red line is the path of the comet approximately from, say, now, the beginning of April, all the way until June. So it's going to be covering this much of the sky. Here in April and maybe even into the beginning of May, it's going to stay right kind of in this area. So this is the area that you're going to look for. In order to look for this, the first thing you're going to have to do is just go out and get familiar with the sky, the different constellations that are around this. So here we can see this is everybody's favorite asterism, the Big Dipper. That's part of this constellation called Ursa Major. So the Big Dipper looks like it's kind of turned upside down right now and dropping all of the water out of it. So this is one of the references for it. This little constellation down in here is really, really hard to see. This is Camelopardalis, the giraffe. So there's a giraffe right here in the sky, but it's really hard to see. All of its stars are those like magnitude 4, 5, 6, just on the verge of what humans can and can't see. And around here, we have a lot of light pollution. So a lot of those stars really get blocked out. This is the constellation of Perseus down here, and Taurus the bull. And this here is Auriga with the bright star Capella. So these constellations are going to kind of be your jumping off point to look for this. I've been using the Big Dipper. I've been kind of using these two stars in the Big Dipper and going about their distance out and trying to look for this star, and then coming down here to the left and scanning around this part of the sky. Now, like I said, it's only at a magnitude 8 right now, which you can't see with your eyes. But you could see it with a pair of binoculars. So I've been taking my binoculars out when I get a chance and kind of just scanning back and forth slowly in this part of the sky. It might not pop out to you, but if you scan back and forth slowly, I have my binoculars here. I usually put them up and I scan back and forth nice and slowly. And you'd be able to find this. It would look like a little fuzzy patch in the sky that doesn't move as you're moving back and forth really slowly. And you have to move around. It's going to be somewhere right around in here. I haven't found it yet, but I haven't taken out my big telescope to point around yet. I've just used my binoculars so that we can do that. So first thing you want to do is get familiar with this part of the sky. There's a link here for evening sky maps. This software that I use, Stellarium, can be really useful. There are stargazing apps for your phone. A lot of people use apps for their phones, and they have the ones that you can hold up and do that. That is really good for learning the sky. But to look for this comet, you might not want to use that. Whenever you look at a screen, even if you have it turned down really dim, it affects your eye's ability to see in the dark. You want to let your eyes get really dark adapted to see something as faint as we are. So you might want to use a map to kind of find your way around the sky, a flashlight with some red fabric or red cellophane over top of it. They sell special astronomy flashlights. They're just red because the red light doesn't affect your eyes as much. But you really want your eyes to be dark adapted. There's also a really cool article here if you want to on how to get your eyes dark adapted and how our eyes work and do that. So get familiar with this part of the sky, but when you go for looking for this actual comet, leave the phone, the apps inside, because as soon as you look at them, you have to wait about 20 or 30 minutes before your eyes really start getting adjusted to the dark and looking for that. Now, finally, this is a map of where you can find this through all the way through June. So you can see here that it's written backwards. This is a European model. So the month is March 20th. It was about here in the sky. March 25th here on the recording, March 30th. And you can see all the way through about the end of April, it'll be in this region of the sky. Now, as it gets closer to its closest point to the sun, as you can see down here, it moves a lot faster. Like I said, as it goes around the sun, it starts to move a lot quicker. So you can see these dots kind of get further out. It would be harder to track down. It's not going to stay in the same spot every night. It's going to be a little bit more difficult to find it. But right now, you should be able to see this. We will have the moon come through the first week of April. Then by about the 10th of April, I'd say this is probably when it's going to be the best to start looking for it. The moon won't be in the sky at that 8, 9, 10 o'clock period. It'll be moving towards or past our full moon phase. So probably after about the 10th or so, you can start going out and you'll have nice dark skies. It'll still be moving slowly and in this area of the sky. So go out, see if you can find it. This is a nice article on how to use binoculars for astronomy. They don't have to be special binoculars. They're not special astronomy binoculars. They're just regular binoculars that you might have sitting around your house. And you can go out there and hunt for a comet. So good luck, and I'll give you an update if I can find it or even if I can image it at all.